Okay, in this sharing, I would like to share with all of you how to answer Minitab question number 2. Okay, so the case given is measurement in growth were made on samples that were each given one of three treatments. So we have three different treatments, and you decide to perform a comparison analysis to determine best treatment with the highest growth. Okay, so this is basically the objective of the question. So when you have more than three distribution and you want to make a comparative analysis, so definitely you need to use the one-way ANOVA, provided if all the three distribution are considered a normal distribution. So the first question to answer is break down the step of analysis and referring to the second page of the Petronas LSGB comprehensive review note that I shared with all of you. All right, so these are all the steps that that are required here. Okay, so if you copy and paste this portion, okay, in your answer sheet, you will definitely get 3 points or 3 marks. Okay, and then the second question will be you need to analyze the data according to the breakdown. So meaning to say, for example, you need to give the answer what is the objective. So the objective of the analysis, you can find the answer from the question itself. Okay, we have two paragraphs in it. Okay, so from here you will get the objective of your analysis, okay, which basically is this statement to determine the best treatment with highest growth. Okay, that is number one. And for step number 2, the answer for step number 2, okay, you need to state the HO and HA, all right, for test for equal variance and also one-way ANOVA. So in hypothesis test, okay, when you do a comparative analysis, we need to proceed with both hypotheses. First is on the comparing the standard deviation, and next is comparing the average or the mean. So in this particular case, comparing the standard deviation can be easily executed by using the test for equal variances, and comparing the average will be using the one-way ANOVA. All right, okay, because you have more than two distribution. Okay, so what is the HO and what is the HA? All right, you can actually refer to inferential statistic module in analyze stage. All right, and you need to search for one-way ANOVA and also test for equivariance. So in that particular modules, you will find how to write down the HO and HA statement for equal variance and one-way ANOVA. Okay, so in short, okay, HO is basically referring towards no different, meaning to say there is no difference in terms of standard deviation or in terms of variance among these three distribution. Okay, so the distribution, the standard deviation of the growth, okay, for treatment 1, treatment 2, treatment 3, for example, is the same. That is HO. So the same HO, if we apply to one-way ANOVA, okay, we can say that there is no difference in terms of the average growth. Okay, HO for test for equivariance, we are referring towards no different in terms of the standard deviation of the growth, and HO for one-way ANOVA, we are referring towards there is no different in terms of the average of growth, okay, for all the treatments. That is HO. HA in general, we conclude HA. If we conclude HA, meaning to say that we are saying that there is a difference. Okay, so HA statement for test for equal variance will be at least there is one difference in terms of variance or in terms of standard deviation for the growth based on the three treatment. So the same statement you can use HA for one-way ANOVA, which is there is ataupun at least there is one difference in terms of average of growth, okay, from all these three treatments. Okay, so that is the HO and HA statement, right? And then you need to proceed with stability test, normality test, test for equivariance, one-way ANOVA. If you do it well, so these two you have 1 point, these two another 1 point, and these two another 1 point. That makes altogether 3 points for the analyze the data according to the breakdown question. Okay, so now I would like to demonstrate how to get the stability test, all right, for every single growth based on different treatment. Okay, so the same thing as question number 1 that I showed in the previous video. Okay, you have three alternative of tools. Okay, so I just use box plot here. Okay, this time around I need to use the multiple Y weight group. Why? Because we have three different distribution. Okay, first distribution is the measurement of growth by treatment number 2, treatment number 1, and treatment number 3. And why I need to use width group? This is because if you can see here, the data for growth is basically stacking one to another. Okay, so for example, row number 1 or number 2 belong to treatment number 2, even row number 3 also the same thing. Data in row number 4 and 5 belong to treatment number 1. Okay, so this is what I call stacking. All right, so because of multiple distribution stack one to another, that's the reason why I select multiple Y width group. Okay, so the graph variable will be the growth and categorical variable will be the treatment. Once you click OK, we have three. Okay, you have three box plot. So it's the same thing. How can we judge that the data we have collected from all these three treatment is free from any outlier? You need to observe the box plot. In this case, there is no star symbol. Okay, so when there is no star symbol, you need to see there is no outlier, and we can conclude that the data is stable. So the data is stable, meaning to say that during the data collection, okay, there is no special cause effect happening, such as typo error, things like that. Okay, so this is stability test result. So for normality test result, again, you have three tools that you can use, but you need to only select one tools and the result will be the same. So in this case, I prefer to use graph, probability plot, multiple, okay, and graph variables. I select the growth, categorical variables, treatment. So I will get all the three p-values in one display. So that is the reason why I prefer to use probability plot when I have multiple distribution. Okay, so in this case, we need to examine ataupun we need to observe the p-value for every single treatment number 1, 2, and 3, and all these three treatment, the growth data p-value is more than 0.05. So meaning to say all these three treatments, okay, are normally distributed ataupun bell curve. Then you proceed with stat, okay, ANOVA, test for equal variance. So this is the first hypothesis, just to compare the standard deviation of growth, okay, among these three treatments, 1, 2, and 3. So in this case, I use the response data in one column, okay, where I need to select the growth and factor treatment. Okay, and since all the three treatments data are normally distributed, so in the option, I need to click use test based on normal distribution. Okay, this is only required when all the distribution are normally distributed. Click OK and click OK. Then I will get this result. Okay, this is the result for test for equivariance that you need to paste in your answer sheet. So the p-value here, okay, for Bartlett test, okay, so the p-value here is more than 0.05, and this p-value is actually for the test for equivariance, which is the hypothesis tools. Okay, any hypothesis tools, all right, any hypothesis tools, when the p-value is more than 0.05, we will conclude HO, meaning to say there is no difference in terms of variance, okay, for all these three treatment. Okay, so that is the most basic interpretation from the test for equivariance. Okay, and now we proceed with one-way ANOVA. Okay, so the same thing, response data are in one column for all factors level because the data is arranged in such a manner. So this is where I need to select the growth for the response, treatment, okay, for the factor, and then I just click OK. So the same thing, it will also provide you with the p-value, and this is also hypothesis test. So the p-value here is less than 0.05, and for any hypothesis test, if the p-value is less than 0.05, we conclude HA, meaning to say, in this particular example, for one-way ANOVA, there is a difference, okay, there is a difference in terms of average, okay, of growth based on treatment. And if you want to find out which treatment that has the highest growth, then we need to look into more detail here. So in this case, we can see treatment number 3, okay, has the highest mean comparing to all other two. All right, 55.5684. So we can conclude that there is a difference in terms of the average of growth, and treatment number 3 is the best treatment that we need to proceed with, because it will give you the maximum result of the growth. So that is how you answer question number 2 and interpret the result only for the equal variance based on the p-value, and also one way ANOVA based on the p-value. Okay, so remember, when you proceed with hypothesis tools, p-value more than 0.05 indicating HO. There is no difference, be it in terms of average, okay, if you refer to one way ANOVA, or there is no difference in terms of standard deviation if you are referring to the test for equal variance. But if the calculated p-value is less than 0.05 or equal to 0.05, then you will conclude there is a difference in terms of average if you are referring to the one-way ANOVA, or there is a difference in terms of deviation, standard deviation or variance if you are referring towards the test for equal variance. Okay, so this is the guideline how to answer question number 2 from the Minitab question. All right, that's all. Thank you.